Just don't do that yourself. Okay, good morning. Welcome to the next session of Machine Learning Coffee Seminar. Apologies for the slow beginning. It's due to us, fortunately, finally having the winter, right?
Yes.
Which means that the trains are not going, at least some of them. Today, we have Professor Julia Jakucci from University of Helsinki, active person at AI research also, who is going to talk about the highly interesting topic. And I have to apologize, I need to leave midway, but Julia promised to handle the end and take the questions. Welcome.
Thank you, Sami. Thank you. So I guess you all have puro, coffee, everything to make this session enjoyable. So I'll do my part to make it enjoyable as well. So here in this, I think 40 minutes or half an hour. I think half an hour. Now we are even through 2 minutes late. So in less than half an hour, I'll try to run through some cases we have had in trying to use physiological signals while people are interacting with information. And so I'd like to pose our question: is this possible? Can one find some use into this? And we'll try to answer the question by looking at 3 cases and see how far we come in answering this question. Maybe one small addition might be that we might ask, well, what if we try to do this in a bit more realistic settings, as a lot of experiments that have been done using physiological signals have been traditionally in highly controlled settings. But so what should we, would we talk about? I'll try to reflect together with you a bit on what we mean by physiological signals and see what kind of signals and measures this might be. I'll spend maybe, given we just have half an hour, maybe just a few words on what one might mean by implicit interaction, and then we'll look at 3 cases. One in which people read news, another one where they look at some comic strips, and finally the most entertaining of all, while people look for some research papers in scientific literature, and we'll see how these 3 cases might help us answer this question. So, but let's start with physiology, physiological signals. I think what we mean mostly, these are a lot of different signals and sensors that have been mostly used in the medical domain, and that little by little are moving towards other areas of life, not just even sports. So you might think of that, of course, if we might measure our pressure or heart rate in a medical situation, but this we do also in a sport. But as soon as you go out of these very specialized and professional areas, also the military possibly, but into everyday life, then I think there are possibly different challenges you have to face. One of them you see here quite well portrayed by how these things might be more and more integrated into consumer electronics that you can wear and use every day, or even implant in your body. So what I'll do now, I'll just take some examples of physiological sensors and just comment a bit together with you what these are. So the electrodermal activity, this just measures the electrical property of your skin that changes, for example, when you get excited or when you do sport, and this kind of sensor has been used, also has differently, it used to be called galvanic skin response, but that kind of term is not used anymore. And in human-computer interaction has been used or what's the best way to say it? People have attempted to use the EDA to measure arousal, engagement, stress. I think all of these things have been reported, have been done, but of course I think that some of you might have, because there are several people that have done studies with physiology also in this room, but you might agree with me that conclusive studies, examples on products that really use these kind of things are rare or non-existent. So there is a good promise though. Then another type of signal could be different cardiovascular signals, and this has been used in HCI for mental effort, workload, again stress, arousal, and also for some, there you see what kind of recording there are. Then electromyography. With this you can basically measure muscles in the face. That you can also think that, okay, when we smile there is a lot of movement of muscle going on, but this measure also very micro movements of the muscles. So it's not just about people smiling, but it's really about how we react with our muscle to some physiological situation. And also respiratory partners have been used, as you can see, test demand, test difficulty, this have been used. And again, I think most of the study you will find are done in very controlled settings. Then quite popular recently is the EEG. This, of course, there are also different other methods to measure the brain signals. This is just one of them. And also very important, I would say, that has been used extensively is eye tracking, and that can be used for a variety of different things you see there, and also pupillometry. I mean, if now you have, or we have seen a kind of a list of different catalogs of possibilities, and just so that we understand what do we mean by physiological signals. We actually refer ourselves most of the time to narrow physiological signals, to include brain signals and other peripheral physiology. And what I wanted to add is maybe in the literature what you usually find is if people try to reflect how physiological signals have been used until now. Well, of course, people have been doing a lot of study trying to classify, and for example, by emotion types or other type of classes, and then predict something. Biofeedback is something quite interesting that is used even in therapy, whereby a person is exposed to a visualization of the own physiological signals, and that it's helpful in helping us, let's say, control or understand our emotions using different type of therapies. And entrainment is has this quite a difficult term, but it basically means that let's say you want to relax, and then we have a stimulus that help you do that, and the physiology is there to see that you actually get to a certain mood or status, physiological status that you're trying to get to. This is, let's say, an overview of what we mean by physiology and how it has been used mostly until now. And so now we will also see how, let's say, the use of physiology in interacting with information, how this can fall into, let's say, what kind of this category. I think possibly this, it might mean that the field, after all, is not that old, and that maybe there will be more application areas arising from this. So, but at this point, maybe we can spend we don't have much time, but just a couple of minutes reflecting on this concept of implicit. I have here a table, I'll soon show it in a few seconds. This is a paper taken from a paper we present at CAI this year, where we actually went through all the possible definitions that people in the field have been using when talking about implicit. So when something is implicit, might be because it was not, or the degree to which it's aligned with the intention of the user, how much the user is paying attention to what is going on, and how much the process associated with a certain type of interaction is unconscious. This concept of implicit is very much coming from psychology. And of course, we can. There are so many definitions, but what we mean here is that in our case of physiology. So if you think that how we have used physiology until now, that means measuring bodily reactions to an external stimuli or trying to infer an inner mood or state. What we are interested in terms of the implicit is be able to interact with the user, not just with an explicit command and with the, let's say, more conventional explicit interaction, but form a different channel where the user can either not even be aware that it's giving feedback to the machine, for example, or it doesn't have to, let's say, invest that much conscious and explicit effort in doing that. Yes, so this was very fast, but I thought it was important to just agree together on what we mean by physiology and by implicit. Very, very fast, but of course both things could deserve much more deeper treatment. So now the fun part. Let's look at the cases. One thing I'd like to say in terms of the research story is that actually here you see we'll start talking about news and then go into humor and comic strips, and then we look at search in scientific literature. What it's nice to also report to you is how we worked in our team. Actually, there are several team members here that we work together on some of these cases. But we started looking at people looking into, for information seeking and looking for research papers in scientific literature. And then in trying to apply physiology in a realistic way, we kind of went a bit away in some of the experiment from that setup, in the sense that we felt that, or we had this intuition that to really find a compelling use case with physiology is really realistic. Looking for scientific literature is a kind of a challenging setting. Imagine, actually some of you have probably been a user in our experiment, so you're asked to come into a room and somebody tells you, now you look for, I don't know, something about robots. And of course, that's not what you were supposed to do that day. You have other things in your mind. And so it's a kind of very artificial situation. We ask you to look for some research papers so that we can do the experiment. And of course, we tried from the physiology to infer maybe something about how you think a certain paper is relevant. So that's why in trying to address this problem of realistic setting, we moved out of the scientific literature. First, we looked into news, as we thought, well, news can be exciting. That might, I don't know, cause different type of emotion go on, and therefore some interesting in a realistic setting so that you can just decide which news site to browse and so on. And then finally, if you want a bit even more extreme case, is the comic strips that should really be giving you a much bigger, let's say, if you think that somehow a lot of our physiology is well linked to emotions, then the comic strip could be a good place as a compelling use case where we can actually observe very well physiological responses. So I just wanted to tell you this story because now, in the way I arranged the cases, you don't see this progression of how we were looking for these use cases. But let's have a look at here. You see some of our collaborators and authors, where you see this case reported. So what we were trying to do here, I think we were inspired by the major Italian newspaper, Corriere della Sera, had for some time, I don't know if they still have, but for some time, when you were reading a news, you would also see an emoticon that was representing how people felt about that news. And that kind of got us quite interested about this, because the way it worked back then, it was you read the news in the website, then if you're logged in, you can actually choose an icon. So is it happy? Does this news make you feel happy, angry, neutral, and so on? So you have different choices, and that kind of got us into thinking of this use case that when you're reading some news, then there could be an implicit interaction with a system that is able to understand how you feel about this news, and without you having to actually choose anything. And this is somehow what got us into setting up this experiment, although the real objective here was to find a realistic scenario where we can really use physiology while interacting with information. And so how we did it is through a proxy, we were able to put a layer on top of the browser of or the page that the user was browsing. And so the user could very easily select any type of news website to look at, and basically then the user was given the opportunity to, as you see, score, does this type of news make me happy, sad, angry, or I'm neutral with it, and then we had some other type of icons. This was mostly for us to be able to, of course, collect a ground truth. Here we really went, we were trying to really make the case of a realistic scenario, and therefore we tried to do everything with just one sensor. And that's also why I use this as a first case, as later you will see a bit more complex cases. So EDA, as I don't know if you're aware, but you can easily now buy several type of measuring devices for EDA that are even nicely designed to fit as a ring on your finger with very nice designs, or bracelets and so on. I think that the real only use I've seen is almost a medical use that I've seen that it's really compelling, more than being for stress or other type of things. I think I've seen one bracelet. I think you probably have seen it in the distinguished lecture of Rosalind Picard, the bracelet that is able to predict if you're going to have a seizure. That's a very compelling scenario. But here what we are trying to do is to see, can we fit a very, let's say, wearable device in a realistic setting. And we did this with 24 participants that could choose the article of choice, so we really tried not to control that much after all. And basically, what came out of the main result, I would say, that you can see here, is basically that we were able to see the better results with news with the negative effects, and this give us, I would say, if we started doing this, trying to get classify or predict a different type of emotions for news, in the end we were able to understand if something was neutral or negative. And so I would say that if I would have to summarize the experiment, is that it showed some promise. We were very happy that we could do this in a very realistic situation, but it was not extremely conclusive in a way. So a lot of work still can be done. So now another case I'd like to show is where we try to predict humor from comic strips. Here again, let's keep this. Here again, the idea is to see if something is neutral to me, is funny, or I don't get it. And what we did here, a bit more complex setup. So we had one EEG channel, one skin conductance, and a cardiovascular activity. So in particular, in this experiment, we were also interested to see, let's say, okay, in the news experiment, we just had one type of physiology. What we're trying to do here is to see, is there an added value in fusing some of these signals? So here you see also some information about the prediction setup, how we split the 22 participants, and how we operated the prediction. But let's go to see what the results told us. So that's not very visible, but I'll try to help looking at this. So here you see basically this is EDA, EEG, and ECG, so the three signals we used, and you see that by fusing the signal, you actually get better results. This is, I would say, we've run many experiments with different type of physiology. It's not always like that. So we were really happy about this this result. It's a very interesting result, especially in such a realistic setting that we chose. One interesting thing to look at is we used as a I don't know, as a baseline, if you want, the video, the emotion detection as coming from the video. So you probably know that there are off-the-shelf modules that allow you to extract emotion just from the video. So we think that, I mean, the motivation of why we didn't use the video right away is that, okay, we think that the video is definitely a very good baseline. It's very easy to use, but also has some drawbacks as, for example, let's say you're in a bus. It's hard to have a video in front of you looking at what you're doing all the time. But, and also it might vary from light condition, but also the physiological sensors have their own issues. And in particular, for example, they are very susceptible to what else you're doing. You're walking or what else is happening. But here you can see a nice result with that we were very close to the performance of the video with the fusion. And then we even tried to combine and fuse the physiology with the video, and we get even a bit better results with that. And yes, let me see what else I have here. Yes, here you see the difference of predicting within participants or across participants. But let's just try to summarize, as we have just one more case to go through. So I would say that it is a valid alternative to think of these physiological sensors, as we were very close to the video performance, and really big added value of fusing the signals. Although, as I said, it's not always the case. It would be interesting to understand when and how is there a reason of understanding when does it make sense and where not. It's a really interesting question. Have no idea at this point. So let's then look at a much more complex case. I left this for last. That is just coming out in the JSIST journal, done in collaboration with TU Berlin. And so again here the idea of why you might want to use implicit feedback while looking for information is that, well, there is more and more information available, and let's say collecting user feedback for what type of information you're looking for or what you might be interested in becomes more and more complex, and it's definitely not viable to ask too much from the user. So we should try to get the better ways to collect this information, which is many times is done over time, like Google does, looking at what you have in your email, what things you browse, and so on. But here we were trying to make the case, well, maybe you need also to collect feedback in a shorter amount of time, as some of your interest might be very session specific of what you're doing in that moment. And so let me just show you a bit something about how we put together this system for searching articles. So basically you have very conventional list days system. In addition to that, we had a way for users to give some feedback. So the semi-realistic setup is that here you're allowed to give one explicit feedback of something that helps you iterate the search, and then the rest is collected using eye tracking and the brain signals. And so let's say the idea we had is that while I look at the keyword that I might be interested in to select the explicit feedback I want to give, we are able to collect all the implicit feedback and understand how much you're interested in each one of these. So this is more or less how it works. To explain a bit better, let me show you a picture. So here you have the user that has a mouse, but also we collect eye tracking. We know exactly where the user is looking at in this, which keyword is looking at. Of course, we have the EEG, and then we have built a physiological classifier, which was built, was trained before the experiment using a training data set, a very simple training data set with words into categories. So nothing as complex as papers, scientific literature in computer science. And this allows us to then, while online, while the user is looking at the keywords, to try to understand if something relevant, and together with the explicit feedback, then we have the search system is able to retrieve results, and then it's kind of a cycle like this. So yet another picture just to show you, okay, how this was built, and in particular how the eye tracker is instrumental in allowing us to, let's say, assign the physiological responses to the different keywords. So to do this, we ran with 16 participants. Again, yes, I'd like to stress this idea, I don't know how clear it was, of how this works is that imagine you have to you get your participant, and before you run this online phase, you try to get this knowledge. I call it knowledge. This physiological classifier by having the same users, so you can train per user. You can trying to train the classifier based on a much simpler experiment, which we call the calibration phase, and where instead of having papers and queries, there is simply users are given a category like fruits or very simple categories, and then they see terms appearing on the screen, and we are able to try to understand the physiological responses in terms of relevance and build them into the classifier. And then when the user finally searches the things, so then the system is already trained, but it's trained on that very simplified data. Okay? I hope you got it. It's a quite complex experiment. All right, so now we have time to comment a couple of the results. Again, here it's barely noticeable anything, but basically what you, this is basically the calibration phase, this experiment where you see that it's between 0.6 and 0.7. The idea here is that this is a kind of non-realistic ideal situation because to make the example of the category of fruits, if something is an apple or an orange, you know already it's a fruit. There's too much less to discuss, is this a fruit or not. But with papers, that's, you start to use topics of papers, that's much more uncertain domain. And giving these premises, basically we were able to show this is basically what we are able to detect in terms of relevance, that you can see we are slightly above chance in terms of understanding that this keyword you probably were interested into. And this we are able to do slightly above chance. And then I can see Pedram there that developed this algorithm that allows us to use the explicit feedback to correct the implicit feedback, and we are able to make this much more noticeable, this effect. Knowing something a bit more from the user, in particular what explicit feedback the user has given. And so this is basically what I wanted to show in terms of cases. I'm 1 or 2 minutes over time, so I just finished. It was possible to demonstrate, no, it was not possible in this experiment because you didn't have yet time to ask, but I'm sure that would have been your question. But were you able to help these people in searching? We were not able to show any task improvement, but we were able to show that it's possible to infer relevance feedback, because we were above chance, we were able to show that we are able to detect this relevance from physiology. So, overall conclusion, realistic techniques do pose more difficult challenges, and implicit information can be obtained, and training and predicting with few participants already delivers promising results. But where to go from here? Well, first of all, the answer is it might be possible to use physiology, but we are probably a bit far from really showing the benefits and the task improvements and so on. But I think these are promising results. And the question is maybe more where to go from here. If you think that all these experiments were done with just few subjects, if you have, I don't know how many 100,000 millions of physiological data, maybe you can be really fantastic at predicting some of these things. Thank you very much.